welcome to Inside SaferAI. I'm Harry with Blue Dot Impact. We run weekly conversations with AI safety orgs, and today we're here with SaferAI, a nonprofit building the risk management infrastructure for governments and labs to use to measure AI risk, quantitative risk modeling, frontier lab ratings, and technical standards. Joining us is Henry, the executive director, and Jakub, the research scientist leading their quantitative risk framework. Henry will cover SaferAI's work streams, theory of change, and then Jakub will get into how you actually translate AI capabilities into measurable harm estimates. Drop questions in the Slido at any time. I'm going to paste that in the chat. It should also be in your email. And this link will go on to YouTube. This meeting will go on to YouTube after. So yeah, Henry, take it away. I think you're going first.
Thank you so much, Harry. Thank you for welcoming us. Hi, everyone. Nice to meet you. I'm looking forward to this discussion with all of you. So as Harry mentioned, I'll first talk about generally what is SaferAI, who are we as an organization, and then I'll hand over to Jakub for a deep dive in our risk modeling work. All right, starting with, so who are we at a glance? We're currently a European-based nonprofit. We have an office in Paris and one in London, and we're half remote. We currently hire 14 people. You have a snapshot of all of them here, including Jakub, who is also in this call. So what are we here to do? We're here to reduce the risks posed by advanced AI, focusing on the large-scale risks. So our mission statement reads like this. We work to reduce large-scale AI risks by building the governance and technical infrastructure for good risk management. So as this sentence suggests, we work in an integrated fashion across more research things and more governance things. So we currently have 4 work streams. One of them is risk modeling, which is more research-oriented, and Jakub will tell you more about. One of them is standards. One of them is frontier AI risk management, and the last one is policy. So I think there is a big argument to do all of this inside the same organization, and it's quite mutually reinforcing to do that rather than have like 4 different organizations that work into each of this in silo. I can tell a bit more about that if I have time at the end. So I'll now talk to you about each of these 4 work streams and give you a bit of a sense of why we work on this and what we do in that work stream. Starting with the risk modeling research stream. So the question is, why is this important? The process we underwent through which we decided to focus on this is, first, we looked at the risk management practices from other high-risk industries. So our baseline assumption is that there is a lot to learn in other high-risk industries and potentially a lot that we can draw from to AI. So we looked at other stuff like aviation, nuclear, etc. And then we proposed, drawing from that, a risk management framework for AI. Then we looked at all the practices, all the current practices from AI companies, mainly drawing from their risk management frameworks, so their responsible scaling policies, frontier safety frameworks, etc. There is roughly 11, 12 of them that are published at the moment. So we analyzed all that, and we identified risk modeling as one of the key blind spots. So basically, risk modeling, Jakub will tell you more about the content, but we want to contextualize the risks more and understand how risks happen in the real life. So it's not only about measuring what cyber capabilities does the model have, it's understanding exactly what are pathways to arms from using these capabilities and creating cyber attacks in the wild, basically. And so we're currently doing research on that. We're focusing at the moment across cyber, CBRN, and loss of control. And maybe one little piece of insight that I find interesting, and like our approach to this, is that we don't only want to do research and drop papers on arXiv. We also want to ensure that the right stakeholders use this research and do proper risk modeling. So in that line of thinking, we're currently collaborating with 4 governments and ACs on that. So with 3 of them, we're doing cyber risk modeling, and with one of them, we're doing CBRN risk modeling. And so this is like more the governance partnership role. So like we take what we've already learned and help governments implement this in their specific context. And then going forward, I would love to collaborate as well more with AI companies. So for loss of control risks, for example, it makes a bit more sense to collaborate with companies than governments, I believe. Okay, so this is the more research side of things, focusing on risk modeling. As I mentioned, we want to ensure that we know how to do good risk management practices, and then these good risk management practices are used in practice. So this brings me to the second stream, which is standards. So maybe a few words on why I think that standards are important. Basically, as opposed to some legislations, standards have some very interesting characteristics. They have buy-in, a very interesting buy-in from industry, because there is industry in the drafting room early on. So these standards process at ISO, for example, work on a consensus-based process. So you have experts from the industry in the room giving early input on what's doable and what's not doable on the text. And then when the piece gets out, it should already be quite consensual among companies that these are best practices. And you would very often see companies adopt these standards on a voluntary basis. So for example, Anthropic has been compliant with the standard 42001, which is one risk management standard. And then another piece of information of why standards are very important is that ISO is one of the only fora where you have American companies and Chinese companies. So you directly have an international buy-in there, as opposed to if you do legislation in the US, then this doesn't apply to to Chinese companies, obviously. Okay, so in terms of what we're doing, we're currently working mainly on risk management adjacent standards. We're leading the high risk management standard in the EU and the LLM evaluation standard at ISO. And then we're giving input to most of the AI safety adjacent standard in the main jurisdiction, basically. So EU, ISO, and NIST in the US. Nice. The third stream is policy. So this is another way to nudge companies to adopt good risk management practices. Here we have a bit of a bimodal approach. We have a mix of reactive and proactive approach. So what do I mean by that? Reactive is basically there are a bunch of live policy process going on. For example, there is the EU AI Act being drafted in the EU, the Code of Practice being drafted in the EU. We will want to come in and give input to that. So this is more like a reactive fashion, as in this is happening anyway, and we come in and give our expertise to support that process. I feel like, so this is very important for sure. There is like a big question about what's doable in policy and what's a bit the plasticity window. And it's much more doable to bring good practices in an existing process than to start a new process from scratch in a completely jurisdiction that is absolutely not thinking about this at the moment. But still, I want us to also have some more proactive policy angles. So I think it's good to also have like constructive, proactive vision for policy and not only react to existing processes. So that enables us to be a bit more ambitious. And so the current agenda we have on the more proactive side of things is more of a focus on middle power and currently the EU. And so there is a big question among these jurisdictions about how can we gain more sovereignty on AI. And so the angle that we are proposing to the EU is that currently one big part of the value chain, which is quite neglected, is the fact that these LLMs are not reliable and therefore very hard to use in a more high stakes deployment context. And so the whole sections of industrial sections that can absolutely not use these AI tools for now. And so our argument is that there is a big argument to focus on this as a middle power or as the EU, in the sense that if you become a key player on that very important part of the value chain, then you have one key value proposition to the table, and you gain one strategic sovereignty leverage, basically. So this is the type of more proactive vision that we're trying to bring to the policy table. And this is the main one we're focusing on right now. And another one that I'd be keen to explore, which also makes sense in my mind to middle powers, is the question of how, if we assume that there is a proliferation of AI capabilities that will create cyber risks, for example, as we've seen a bit with Mythos, how can we ensure that countries are resilient to this proliferation of capabilities and do policy proposal to nudge that resilience faster? Okay, so that's at a glance how we think about policy and what we do there. And then the fourth one is frontier AI risk management. So here, it's not talking more about like standards or policy, but directly thinking about the companies. So our longer term vision, and this is what's going on in other high risk industries, is that you have strong risk management practices that are adopted by the companies. And then you have a very rich ecosystem of third party organization that can come in and audit and verify these practices. So this is a longer term vision that I think would be very beneficial for AI safety. Now, to get there, there are a ton of little ingredients to get right. So one of them is that you probably need a good standard that reflects these practices that can be audited against. You probably need some incentives from the companies to get audited. So that can be regulation, that can also be access to customers, access to insurance, access to the market, etc. So this is more like a governance question than keen to look into. And then you also want to develop this ecosystem of third party. And so here, the first steps that I want to take on to get there is that I want to start collaborating with companies on improving their risk management framework and implementing it. So on the improving the risk management framework part, so you can think again about this as the responsible scaling policies from Anthropic. This is something we've already done with 2 frontier companies in the past, and that I want to continue to expand. And then there is the whole part about how do you actually implement this in practice. So it's not only about writing one document, it's also like about how do you make this work in practice in the company. And one thing that we will be looking at in the very near future is some third-party evaluation. So the code of practice gives a very interesting window because a lot of companies that are a bit less experienced with risk management suddenly have to do a whole set of new practices. And they are requiring, it would be helpful for them to have external help to support them through that process. And one of the things that they have to do is third-party evaluation. And so right now we're discussing with 4 or 5 companies to be that helping hand as an organization. So that was the 4th one. Maybe one quick word on why do I think that this is mutually reinforcing, as I mentioned at the beginning. So it's like really like a bilateral discussion, basically, from the governance to the more research side of things, knowing what's tractable and implementable in governance. So being in the room where the standards are drafted, where the policy is drafted, and giving input there gives you a very good sense about what's practically implementable in governance. And so this will inform our research agenda in the sense that we're going to do things that are actually enforceable in practice. And then the opposite is also true in the sense that if you have more technical expertise working with these companies, expertise working on the models, you can also give more informed recommendations to standards and to policy. So I really see this as a bilateral reinforcing relationship. Okay, and then a few words on open roles. So we're currently hiring for a bunch of roles. You can see more information on our webpage careers. So one is standards researcher. We want to expand that team. We already have very good access and trust in standards bodies. So now it's more about delivering and giving input to all the standards process that we have access to. And then the 2 other open roles currently are for the frontier AI risk management team. One of them is a governance researcher role. So here it's more going to be about giving input on the risk management framework to the companies we're working with, analyzing the risk management practices of all companies. And then the 3rd one is a more research engineer role. So this is more technical infrastructure part and technical research part, as in setting up our internal process and running third-party evaluation, for example. These are the 3 currently ones. We're also probably going to open more soon. So you can stay tuned, look at our careers page, and also reach out to Ren. Her email is here if you have any question about any of them. And one side note is that we are currently hiring for a contractor for the next 3 months to run third-party evaluation. So if you have any experience with Inspect and React, feel free to drop me an email, ideally by like tomorrow, because we're closing this by Sunday. It's a bit of a quick one. Cool, that's enough for me. Thank you so much, and I'll now hand over to Jakub.
Yeah, thanks very much, Henry, and thanks very much to Blue Dot for organizing this event. So, as Henry mentioned, my name is Jakub. I'm a research scientist at SaferAI. More precisely, I'm on the risk modeling team. And today in this presentation, I would like to tell you about, first of all, what risk modeling is, why we do it, and hopefully how you can contribute in the future. So, first of all, what is risk modeling? Many of you are going to be familiar with the concept of AI evaluations, but one thing that often goes unsaid is that AI evaluations are only imperfect proxies of risk. Because if you really think about this, AI evaluations are those very sterile, abstract tests of capabilities of AI systems, right? But they do not fully cover the sort of scenarios and risks that we can expect from AI in the real life. Real life is very messy. Real life cyber attacks are highly non-sequential. They can take multiple pathways. There are the offensive and defensive cat and mouse type of dynamics, right? So it's very hard to capture all of this stuff with benchmark evaluations. And here's where risk modeling comes in. The idea of risk modeling is that you collect such pieces of evidence given to you, for example, through AI evaluations, and the risk modeling is supposed to be this exercise that bridges the gap between sterile abstract tests and the actual real world impact. Okay, so the first thing I guess to note is that this is a very understudied subject in the context of AI because everybody seems to be doing AI evaluations, but there aren't that many organizations doing risk modeling, and SaferAI happens to be one of such few organizations. Next slide, please. Thanks. And so to demonstrate that this is really the case, the need for risk modeling is true, and I haven't just made it up for this presentation. I wanted to show you this extract from the Code of Practice. So this is the safety and security chapter of the European Code of Practice. And as you can see, if you want to be compliant with the Code of Practice, you need to perform the following 5 steps in your risk assessment. And specifically, if you notice, model evaluations only constitute one of these 5 steps, right? The other 5 steps that you need to abide by if you want to be EU AI Act compliant have nothing really to do with model evaluations directly. AI evaluations are only a component of the full procedure. So 80% of the work that you need to perform if you want to demonstrate to the regulator that your system is safe to release on the market is actually not about evaluations, okay? And this is kind of the gap that we are trying to close with risk modeling. Specifically, we're targeting the third bullet point here. And just one quick note. So the EU AI Act talks about systemic risk areas. Specifically, they define 4 systemic risk areas: cyber offense, CBRN, loss of control, and harmful manipulation. So far at SaferAI, we've covered mainly cyber. We are now also working on CBRN. I'm going to mention this in a second, and also branching out to loss of control quite soon. Okay, next slide, please. Thanks. So having justified the need for risk modeling as a research agenda that AI safety world should be pursuing, let me give you a bit of a breakdown into what this actually looks like in practice. So at a super high level, I would say that risk modeling can fall into 3 categories. The first category is purely qualitative. So this is basically textual descriptions of viable pathways to harm, right? So it's you sitting down and thinking hard about the problem and being like, okay, I think that this might happen, and somebody else might disagree with you because there is a crux in the argument and they just do not buy that this thing is going to happen, and they have a different scenario in their head, right? This is fine. As you can imagine, this is often very imprecise, and you can spend hours upon hours arguing with people as to what is a realistic description of a risk pathway. Then we have approaches that I would describe as semi-quantitative. So if you look at many risk assessments, risk indices, sometimes they're called, people often say things like, we judge the risk to be low or high or severe, right? So this is kind of splitting the full risk spectrum into discrete bins that you call low, medium, high, severe, and allocating your scenarios, your AI models that you're evaluating or assessing, I should say, into one of those bins. So this is, between qualitative and quantitative approaches. The problem with this is that people have very different definitions of what constitutes the word high, right? So if anybody here is familiar with the book Super Forecasters by Tetlock, he gives those great anecdotes how, for example, CIA analysts would report to John F. Kennedy that the probability of some event was severe and should be taken seriously. And then if you actually ask those CIA analysts what they meant by severe, the answers are from 20 to 80%. Okay, so this is not very precise. Then at the other end of the spectrum, we have fully quantitative approaches, which are basically trying to give a number at the end of this risk modeling exercise. So the goal here is to say, okay, we estimate that the expected annual damages due to some cyber attack globally are going to be $1 billion or something like that. Okay, we are obviously not trying to get it down to the individual cents or dollars, but roughly within the right order or half order of magnitude. That's the ideal ambition. There are many advantages to the quantitative side of risk modeling that I'm going to talk about in a second. The main disadvantage, I would say, is just that it's very hard. Okay, and that's the problem that we're having to tackle constantly at SaferAI. But yes, so SaferAI overall is more on the quantitative side, definitely between semi and fully quantitative, I would say. Okay, so what does quantitative risk modeling look like in practice? Again, as a schematic overview, we essentially decompose the overall risk into the following 4 factors: the number of actors that can potentially attempt such an attack, number of attempts per actor, once they attempt it, what's the corresponding probability of success, and if they succeed at an attempt, what is the corresponding impact? Okay, so the first 2 factors, they can be perceived as we're trying to understand how AI is going to raise the floor. In other words, how many new actors and new attempts are going to be enabled by AI. A good example here, I think, is spear phishing, right? So spear phishing is something that can be attempted by any human in theory, but it takes a lot of effort to crawl through somebody's LinkedIn page and private information, that sort of stuff, in order to craft a really, really good spear phishing email. But now with LLMs and their capability to process vast amounts of information and synthesize it, this really makes the problem almost trivial, right? So we have suddenly raised the floor for the attackers. On the other hand of this, on the other end of the spectrum, we have p-success and impact, which can be loosely perceived as raising the ceiling, right? So for actors that were already attempting a given attack, AIs might, for example, provide better debugging tools when it comes to cyber attacks, or they might have better specialized cybersecurity knowledge that any individual hacker will not possess, right? So for those people, essentially the probability of a successful attack is going to be raised, and also the corresponding impact. So that's the general idea. I'm going to talk about this a bit more on the next slide, but what are, sorry, if you could go back to the, yes, let me just quickly mention the advantages of this quantitative approach. First of all, because we have such a decomposition into distinct factors and we aggregate those factors into the overall risk, we can then perform attribution analysis, where essentially we say, okay, I estimate the total risk to be this many billion per year, but I can also tell you that 70% of that risk is going to be through increased p-success, and maybe 15 due to increased number of attempts or something like that, okay? So not only do we get information about the total level of risk as quantified through, let's say, financial damage, but also I can tell you where this risk is coming from. And this is really useful both for cyber defenders, but also for regulators like the European Commission. Another useful thing about being quantitative is that it forces us to be explicit about our uncertainty and disagreements. So this is essentially what I alluded to a few minutes ago in this example with the CIA experts, right? If we use vague words, we're going to get vague analysis, essentially. And also, being quantitative plays nicely hand in hand with this idea of regulatory thresholds that you might be familiar with. So here the idea is that a regulator might decide that some level of financial damage due to cyber attacks is unacceptable, or perhaps some level of expected lost lives due to a biological attack is unacceptable. And if we are able to quantify the level of risk in our risk models, we can then tell the regulator, okay, this level of risk has been crossed or it hasn't been crossed yet. Okay, so those are the 3 main advantages of doing things quantitatively. Next slide, please. Okay, so This, I just wanted to include this slide to show you that reality is more complicated. So what you can see here on the screen is basically a screenshot from our website that I'm going to link in a second, where we decompose one particular attack pathway into distinct steps, okay? So this massive collection of nodes here represents different factors that need to be estimated in order to calculate or estimate P success. For those of you familiar with cybersecurity, we use the MITRE framework, the MITRE attack framework. So we decompose the successful attack rate into individual MITRE tactics and techniques that you can see here on the screen. For example, initial access, resource development, privilege escalation, command and control, and that sort of stuff, right? But yeah, I'm not gonna go into any further detail here, but the point is that we put quite a lot of effort into really trying to ensure that those attack scenarios are representative. They are broken down into individual steps that can be realistic and can be expected from the attacker. Yeah, there's a lot of effort designed. A lot of effort spent on decomposing those scenarios. It's not just an exercise where we close our eyes and we say, okay, P success is 27% without further justification. Okay, next slide, please. Once we have decomposed each attack scenario into such diagrams that you saw on the previous slide, then the question becomes, okay, how on earth do we actually estimate the probability of each factor in this attack kill chain, right? And the answer to this is that we need to aggregate empirical data from the real world. This can include AI evaluations, but not only. We can also use historical incidents, threat intelligence reports, and any other pieces of information we can find in the real world. The aggregation of different types of evidence is in itself a big problem, okay? But the idea is that once you have collected such evidence from the real world, which is represented here by the green node at the bottom, we then need to translate this into probabilities on the blue nodes, right? And the way this is done is through something called expert elicitation. So expert elicitation is something that if you have a background in maybe very pure sciences like mathematics, it might sound very disappointing and imprecise, but this is a very established procedure in other industries like aviation or nuclear, okay? So the idea behind expert elicitation is literally that you gather experts in a room and you elicit the corresponding probabilities, risk estimates on each of those factors based on the available evidence. And there are actually very structured methods, very structured protocols for how this should be done so that the elicitation is unbiased, it's objective, it stands up to scrutiny. There are actually entire books that have been written about how to do this well, how to perform expert elicitation well. The problem, or one of problems with expert elicitation, with asking humans about their risk estimates, is that this is quite expensive and time-consuming. And so in order to circumvent the problem, SaferAI at some point in 2025 started experimenting with this idea of using LLMs for risk estimation. Now, this might seem wild, but I think I can convince you that this is not that wild because there is this benchmark called Forecast Bench by the Forecasting Research Institute. And if you go on their website, you will see that they expect parity of LLM forecasters with human super forecasters by around May of 2027. May of 2027 is the median estimate, I think, right? So if we look forward into the future by, 12 months exactly, because today is the 1st of May, 2026, there is a non-trivial chance, a 50% chance exactly, that we're gonna get LLMs which actually exceed the level of human super forecasters, right? So we're trying to be a bit forward-looking and prepare ourselves for this world where we can sidestep human expert elicitation and speed up the whole process with LLMs. Next slide, please. Okay, so here I just wanted to advertise what SaferAI has done so far in terms of cyber risk modeling specifically. So towards the end of last year, in December, we released 3 big papers on risk modeling. The first one essentially was a review of current risk modeling and management and assessment techniques in other industries. The second one was us taking the best of these methodologies and translating them onto the AI context. And the final paper was us applying this AI methodology to cyber risk specifically, right? Specifically cyber offense risks. So we have developed 9 cybersecurity risk models. For each of those, we performed such breakdowns that I showed you a couple of slides ago, those big breakdowns into those sophisticated graphs. For each such risk model, we have then performed the estimation of human baseline. Essentially, okay, what is the level of risk in this cyber scenario where the humans do not have any AI assistance? The reason why we're interested in doing this is because if you think about this, knowing the absolute number is actually not that useful. Like if I go to the European Commission, let's say, and I say that the absolute level of annual damages due to AI cyber attacks is 1,572,000,000, blah, 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 right? This is not a very useful insight. What you're actually more interested in is the differential uplift over the baseline. Exactly. So we're interested in relative risk rather than absolute risk, the uplift over this baseline. Once you've quantify the baseline, we then perform the expert elucidation procedure that I just talked about. This gives us the relative uplift over the baseline. Once we have that, we can perform attribution analysis. So essentially, okay, here's the total risk, and I'm now telling you that 40% of this risk comes from number of actors, and 16% comes from the MITRE step called lateral movement or something like that. Okay, so this provides the regulator or the cyber defender with useful information, useful insights as to where the risk is coming from. And finally, for every single estimate across these 9 risk models, we have rationales where experts justify their opinions for why they think a given risk estimate is 73% as opposed to 62% or something like that, okay? And actually, quite recently, we have published the full set of information about these 9 risk models on this website that you can see here on the right side. So if you go to this link, you will see our 9 cybersecurity scenarios. You can click on each scenario. There's going to be a detailed description of the scenario, a detailed breakdown into MITRE steps, individual histograms, distributions, estimates, uplift estimates, rationales, and some other information that I probably forgot. But yeah, we basically published everything on this website. It's a lot of work. One such scenario, if you dump all this information into a PDF, one such scenario can be like, I know, 60, 70 pages. So it's probably several hundred pages of work on this website. Next slide, please, Amri. And finally, I wanted to quickly reference what we are doing in other risk modeling areas. So when it comes to CBRN, we have been awarded a tender by the European Commission to perform CBRN risk modeling. Actually, not only bio, the full CBRN spectrum. So that's quite an interesting one because the other 3 letters in CBRN are often neglected. This project is executed in collaboration with other prominent organizations in the AI safety space, for example, FareAI, Nemesis Insights, Secure Bio, Equistamp, and GovAI. I think I didn't miss anyone. So it's a consortium of 5 or 6 organizations. And it's a project that's going to be ongoing for the next, I believe, 3 years, quite a large commitment to support the European Commission. As I mentioned right at the beginning, we're also branching into loss of control risk modeling, which is a completely different beast. Doing this quantitatively is probably not feasible at the moment, but we're exploring other, let's say, semi-qualitative or maybe even fully qualitative approaches. We actually just submitted a paper on loss of control risk modeling last week, but it's under review, so I can't share much detail here. Last slide, please, Amri. Right, so I promise that I'm going to talk about how you can contribute. Thankfully, fortunately, or maybe unfortunately, there's a lot to contribute to because it's a very nascent area of AI safety. So I wanted to list just a couple of things that you could be working on and the current open problems in risk modeling. First of all, the classic problem that you might have already thought of is benchmark saturation, right? You look at model cards that come out of the frontier labs, and basically everything is getting saturated. We had Opus 4.5, Opus 4.6. Now we have Mythos, and the cyber benchmarks are going from 60 to 80 to 98% essentially. This is a problem because we're losing information from AI evaluations as to the real life risk that we can expect, right? And this is a real problem that people need to think about. Another problem is that, as I said, AI evaluations are only one source of evidence that we can use for risk modeling. but it's not clear currently to us how to best go about incorporating all types of evidence into our risk models, because some of this information might be very structured, like AI evaluations. Some of it might just live out there on the internet in some blog post of a cybersecurity researcher, right? And we don't currently understand fully how to best integrate this into our risk models. The third bullet point is a very big one. I said that we performed, this review of risk management and modeling practices in other industries, and we were obviously as thorough as we could be about it. But at the end of the day, there's a problem here, because in the context of, let's say, nuclear safety, a nuclear power plant doesn't just spontaneously become more nuclear over time, and it doesn't become more agentic and trying to escape from its confines, right? Whereas with AIs, that might happen. And so it's obviously a very large and unanswered question. How do we best adapt existing risk modeling techniques from other industries to AI, where AI seems to be a very different, fundamentally different system that has agency, has the capability potentially of self-improving and so forth, right? As I said, this space is very nascent. Like the best practices have not been worked out yet. There is no canonical AI safety risk modeling textbook that you can just read and become an expert. Everybody is very confused what they should be doing, and so we really need more people. This is my last bullet point here. We have not enough hands on deck. There's only a small number of organizations pursuing this work, including SaferAI. We actually recently held a workshop where we tried to gather everybody working on risk modeling seriously in a room. And I think there were 25 people or something like that. So there's a lot of work to be done, as you can see, and we would like to see more people working on this. And with this, I thank you for your attention, and we'll be happy to answer any questions with Henry.
All right. Thank you. Thanks for the great presentation, Jakub and Henry. I'm going to be fielding Q&A questions from the Slido. I'll send the link in the chat. First up, from Gabriel. How can we incentivize frontier companies to adopt safe practices beyond the bare minimum required by regulation?
Should I take this? The bare minimum required by regulation. So I feel like, which regulation are we talking about? Like in the US, currently, there's not a lot of regulation. In the EU, there is the EU Act and the Code of Practice. I think that this is already an amazing floor. And a lot of companies were not doing this before. So I think like we should first recognize that this is amazing that the EU has done this, and I think this is like a very good driver to set this common floor for all of the companies. Then in terms of other ways of doing this, I guess I mentioned standards. I feel like voluntary practices from companies, they're not ideal, but they've gone a very long way before, and for a long time they were the main driver of the best practices, right? So this is always something to also keep in mind. And then, as I mentioned, like there are potentially like more levers that exist in other high-risk industries, like access to insurance, access to market, access to customers that could also be happening in the future with AI. But this is a bit more like remote and distant, I would guess.
Andreas asks, what surprised SaferAI most about working inside of standards bodies? What did that force you to change, and what aspects are you still least sure of?
Basically, in standards body, it's a consensus-driven process. And I think that some industries have understood very well how it works. And basically, if you have some actors that are sitting in that room and want to block everything, as everybody has to agree to move forward, it's very easy for a company to unilaterally make the whole process very complicated. And some industries have understood that well and have been very present in standards for a long time. So it's a hard environment to have good practices from a safety perspective, basically.
Makes sense. Have you seen it improving, or has it mostly stayed the same?
Yeah, I'm not sure how much I want to say. I'm not sure I've seen a real evolution. Like again, like this is like a long game that companies have been in for a long time. What's also a bit insane is that it's non-paid work. So you're not paid by ISO if you do ISO standards. And so there is a clear like case where like people who are paid by these companies are paid to do this. And so you have a bit of like this setup, which is not ideal and biased towards more wealthy companies to pay for experts to work on that. I can comment on any evolution on this. So.
We have one with a lot of upvotes. Civil society organizations are notoriously excluded from the standard setting processes. Are you working to integrate their perspectives as well?
So we are a civil society organization. So we're definitely doing part of that effort. I also think that like there is a lot of expertise currently in civil society organizations. And so, yeah, we're definitely encouraging experts from civil society to get into the process. This is something that can be done and that has been done in the past. And we're definitely very happy to have more competent experts from civil society to get involved in there. So if you're one of these people and you have any questions on how to get in there, feel free to reach out to me.
Very cool. One for Jakub, I guess. Do you use off-the-shelf software for risk modeling and Bayesian graphs, or do you see a need for new tools, or what do you usually use?
We have our own pipeline that we have developed for Bayesian networks, aggregating those risk estimates, the empirical evidence into the final estimate of risk. This hasn't been published, but well, Henry can correct me if I'm wrong, but it's not that we want to keep it private. We're a non-profit, so we don't make money on this. We just haven't published it because we want to polish everything up, make it more computationally efficient, and I think that's it, right? But we have shared it with other collaborators, so yeah, we're not making money on the software.
Yeah, and if you want access to it, feel free to reach out, and we can very much probably give it to you. For now, it's a bit buggy, but probably more hopeful than nothing.
Cool. And then Gabriel asks again, how does risk modeling affect the actions of governments and frontier labs?
Should I take this? Basically, currently, there is a lot in most government. There is not so much expertise yet on AI and AI risk. This is for sure a nascent field. And so right now, I'd say that we are at the very early game of risk modeling informing governments. We're working with 4 of them at the moment and are a bit starting the discussion here. And so I don't have like a ton of past success stories from the past 5 years working on this. I do think that this is a necessary ingredient for countries to make informed decision. Potentially what we've seen in the US is a bit of an example of that. They've built a lot of good internal capacity with the UK, my bad. They've built a lot of good internal capacity with the UKAC. They've been able to understand very quickly what the implication of mythos are and make recommendations to company in the UK. So I feel like there is like countries gaining a lot of understanding of what the implications of AI capabilities and what their risks are is, in my mind, definitely a necessary ingredient for them to make informed decisions.
And then we have a more general question, which is, how do you perceive government's awareness of AI risks? Top countries or more middle powers or?
Yeah, so this is extremely variable. And it's the variable in terms of countries we're talking about and variable in terms of risk we're talking about. So I feel like with cyber risks, like basically the fact that mythos happen, like this has been a bit of a one preponderant element happening that kind of a lot of people saw. So I feel like with events happening in the world, it's much more by default the fact that countries and policymakers are getting suddenly aware of it. But this is more after the fact, right? So for cyber, I would say that now, thanks to Mythos, there is much more awareness than before. For the other risks that we mentioned, CBRN and loss of control, a bit less. Though I feel like more people have been talking about it, more bigger scientific figures have been talking about it. So there is definitely like, as we go, a bit of a more general like awareness of this, though I would say that cyber is definitely a separate case because there has been something happening in the world already.
Makes sense. Let's see. Ask for questions in the Slido. Any reflections on the variation between jurisdictions' use of quantitative risk modeling for AI risk? And will the network of AC adopt a common approach?
Can you repeat the question, sorry?
Yeah, so any reflections on the variation between jurisdictions' use of quantitative risk modeling? So how does this vary between?
Yeah. So first of all, like Jakub, feel free to jump on if you want. In the context of AI, again, like as we mentioned, this is super nascent. So we've published this quantitative risk modeling paper in December 2025, and we've been working with a few governments since then. So like this is like really, really early days, and there is a lot to do. And so I couldn't really comment on like all the different way jurisdictions I'm taking this on. For now, it's more like the discussion looks like we're talking with like a few stakeholders in the ACs and in the governments about this. And this is really, really early days. Yeah, so I know that this is a bit of a not interesting, disappointing answer, but this is the state of play at the moment. And it also makes sense, like all of this is so new. And then on the second question, like common practices that the ACs are taking on this, again, like at the moment, no, because this is just so new. And I think that this would be for sure desirable. I think like the network of AC, for example, in the past has been a bit useful to communicate best practices, mostly on evaluations, agentic evaluations, etc. And I feel like opening up to the risk modeling aspect with something that would be amazing and that we're a bit thinking about. But to the best of my knowledge, hasn't happened really yet.
Makes sense. People want to talk more about the use of LLMs as forecasters. When did this start? How did it go originally? Do you think at a certain point it could get risky because of scheming or something like this?
Right, yeah, that's a very interesting question. We have had some conversations about this as a possibility. Well, for now, I don't think there's that significant probability of Sonnet 4.6 or something scheming against us with LLM forecasting. But I don't know, who knows? Maybe in 2029 or something, this is going to become a problem. I think, well, hmm. I guess one idea would be to tell Sonnet 4.6 that it's actually assessing the level of risk coming from Grok or something, so that it doesn't feel incentivized to sandbag on its own risk evaluations. But yeah, it's obviously an open problem. It's the same problem that like MacInterp researchers will be facing, right? Probably to an even larger extent. I think that's what the question was alluding to as like as a hazard of using scheming LLMs. I don't have a fully fixed answer to this. I hope that yeah, the research groups around the world that are using LLMs for coding all the time are going to figure out the answer to this question by the time it happens, and then we can just piggyback off their answer.
That's fair. Yeah, I am curious about that. Like, when did you notice the LLMs getting really good at forecasting? And like, when did it start getting super useful?
Well, I mean, okay, first of all, I should caveat that, the thing that you see on this website, the riskmodels.saferai.org, this is preliminary, like you shouldn't fully trust those results. Okay, we're in the process of, we actually have a SPAR project going on right now, fully dedicated to LLM forecasting, where we have participants trying to calibrate them, figure out what works, which prompt structures work, and this sort of stuff. So this is very much active work area for us. To answer your question, Harry, so we started experimenting with this, I think, last summer. And around the time, there were some results from various startups that are trying to use LLMs for forecasting, often just in the context of the finance industry, because there's a lot of money to be made if you can predict critical decisions that should be made in the context of markets and that sort of stuff. And it's really amazing how well they managed to perform. There's I forgot the name of the startup, but I think the guy's called Toby Chevlain. Maybe Henri can remember. And yeah, they submitted a model. I can't remember what size it was to some prediction market competition, like Metaculus or something, and it came fourth or fifth out of 500 teams, and that was already a couple of months ago. If you go on the Forecast Bench website by the Forecast Research Institute, they have a leaderboard, and I think the fourth or fifth best model is something called Foresight 32B. It's a 32B parameter model. Yeah, I think it was Mantic. Somebody wrote in the comments, yes. Yeah, so there are models that have been purposefully fine-tuned for forecasting with the various types of reinforcement learning, and they can be surprisingly small, right? As small as 32 billion parameters. And yeah, it sounds wild, but many things in AI are wild these days. And yeah, it looks like we're on track for LLMs to surpass humans within 12 months.
That's fascinating. All right, for the last few minutes, we'll switch to more like career-based questions. if someone wants to get into quantitative risk modeling, what do you recommend they do? Do you have training? Where should they do?
Okay, I can maybe take this one, and Ari, you can add on. Well, it just so happens that we have started running fellowships or partnering with other fellowships. So as I mentioned already, we have this LLM forecasting SPAR project. In fact, we have been running 3 SPAR projects in parallel. One reason for us doing this was obviously to increase the research output and capacity of our risk modeling team, but also we understand that this is a very niche area of AI safety, and so we also have to contribute as an organization to upskilling people at risk modeling. And yeah, so applying to a project run by SaferAI is obviously a great way to upskill at this sort of stuff and hopefully be involved in it long term. The SPAR projects are about to finish, but SPAR is running multiple iterations per year. We are also considering doing a full-time project because SPAR is a part-time thing, but over the summer there's well, a substantial probability we're gonna do a project through one of the full-time fellowships, maybe ERA, Pivotal, something like that.
Right, and I posted a link to the SPAR project, but I'll also post some more links. Let's see. Someone says, I'm considering applying to your AI risk management research engineer role. What are you looking for in someone for this role?
Yeah, thanks for your interest. We're looking basically to someone who has experience setting up the infra for like all the things that are connected to the implementation of a risk management framework. So I guess the most classic type of experience you'd have here is experience running evaluation using frameworks such as Inspect, React, etc. So it's very specific, and like I guess like all past experience on attacks, attack and defense, for example, all the way to like fine-tuning attacks to stress test like open source models would be useful.
That's super useful. Someone asks, risk modeling is obviously an area where you feel that more work needs to be done, but what are the other bottlenecks in AI safety in your view? More open question.
I feel like,
Well,
yeah, like, oh,
sorry.
go ahead. Okay, I gotta start.
I mean,
Like, there are like 1,000 bottlenecks, obviously. I feel like one cool one that is emerging that Jakub has a bit mentioned is that currently evaluations are really struggling to keep pace for different reasons. Like it's hard to design a hard enough evaluation that we still have signal. The model is more and more noticing that we're evaluating them, and so now we're a bit at the stage of like, how can we still have signal in these models? Is it even possible to do risk management without evaluation? And so I feel like addressing the specific reasons why evaluation stopped working could be one interesting bottleneck to start focusing on. This is obvious, like we've mentioned a lot that there is a lot of focus on evaluation and less on risk modeling, and I'm talking about evaluation projects. And then something else that I'm quite curious about from not so long ago is that it looks like companies are starting and will do more and more handing over the research and development process of AI to AI models. So this has been a bit started already. I feel like AI models are not super reliable right now. And so we might have a lot of risks stemming from unreliable AI models pushing very quickly and doing a lot of the AI R&D process internally. And I feel like this is completely underexplored at the moment. And we've already seen some companies being a bit sloppy recently. And so I feel like this will increase and increase. And then it's a bit hard to think about how can risk management and engineering be done in a safe way if most of it is done by unreliable AI. So this is like one of a bit of a newer question that I'm very interested by. Okay, I'll stop talking. Anything to you, Jakub?
Well, I mean, this was a very broad question, right? So I don't know if the person asking intended just risk management and risk modeling, but yeah, I largely echo what Henri was saying. I was about to mention, yeah, more realistic evaluations. Like evaluations are really undergoing a very serious transformation right now, I think. Like if you think about a benchmark like GPQA Diamond, which is PhD level questions in biology, chemistry, that sort of stuff. But it's essentially an ABCD type of questions. This has ceased to be an informative metric anymore, really, of AI capability levels. And for example, in the context of cyber offense, people are really now having to spend a lot of effort into designing sophisticated environments for testing cyber capabilities. One of the best examples is the cyber range by UKAC that some of you might have seen. It was released recently. This is very different to like very simplistic evaluations, like capture the flag competitions that the AI has to complete. But it takes a lot of work, right? So if anybody has a strong engineering background, you can work on creating better environments for cyber offense environments, cyber offense evaluations, but don't sell them to labs so that they can hill climb on them. This is a very bad idea.
A fair warning. All right. We have time for about one more question, so put it in the Slido. Someone asks, without an engineering or PhD background, what's the best way to pivot into AI risk evaluation or compliance roles?
Can you repeat the first part of it? What was the background?
Yeah, without an engineering or PhD background.
Do you want to take this one, Jakub? I think you've been through these fellowships in this whole ecosystem more recently than others.
I don't have an engineering background. I have a physics background, nothing to do with AI really. I upskilled personally through those fellowships, through Blue Dot courses, may I add, which were of great value for me. Yeah, I would say that like, maybe with fields of AI safety that are more well established, like if you're trying to get into mech interp now, there are people that you're gonna have to compete with who have already written 5 papers and published them at ICML or something like that. So it has become more hierarchical, so to speak, and you need to have like a strong academic researcher type of CV. With something like risk management, risk modeling, and evaluations, I think there are many opportunities to contribute where you don't need formal background in these things. I don't even know what it would mean to have a formal background in risk modeling. Like you can't really go to university to study a bachelor in risk modeling. It doesn't exist, right? So it's yeah, it's a bit of a hustle, as people say. You have to kind of yeah, maybe do something like a SPAR project, have a collaboration with an organization for 2 or 3 months, and learn those things from the ground up, so to speak. But there is no canonical pathway. There are no textbooks on this. I don't know if that makes it more optimistic or more pessimistic for you, because yeah, it is tough. It's very unstructured, but at the same time, like if you don't have an engineering background, don't worry. I don't have an engineering background. If you don't have a classic academic background with 2 postdocs and 20 papers, that's also quite irrelevant. I think like when I was reviewing applications for SPAR, I really paid minimal attention to somebody's CV. It was more about, can you think well, and can you connect facts, and can you think originally?
All right, sounds like AI safety. You said that the next SPAR, you will be doing another SPAR project?
I'm unsure yet. So SPAR projects are finishing in about 3 weeks, I think. Well, by the way, maybe we can put a link into the SPAR demo day, which is on the 23rd of May. We're gonna have a very big SPAR demo day with 130 projects. If you want to know more about the specifics of the SPAR projects that we've been running, you are welcome to join us and look at our posters. Yeah, thanks very much. For the next iteration, I don't know it. We have to debrief and think what makes sense. But yeah, there is a substantial probability we're gonna do a full-time fellowship, like with ERA or Pivotal. Yeah.
All right. Well, to stay updated with SaferAI, there's their website, but also check Blue Dot events. We'll probably have you back on or something like this if there's like a big career fellowship opportunity. If that's 2025 SPAR demo day. That's my bad. Check that out. But thank you so much, Jakub and Henry. This will be recorded and posted to YouTube. But yeah, thanks for coming up.
Amazing. Thank you so much for having us, Harry, and thank you so much for coming, everyone. It was great to see you.
Thanks very much, everybody.